The confidence interval for a single mean, remember confidence intervals are estimates for a population parameter, in this case a population mean, given a sample statistic, in this case a sample mean. So we've taken a sample and we want to calculate a range of values that we can be confident the population mean will be found in. In this example, the population standard deviation is known, and if you skip down here, this assumption that you would know the population standard deviation is rare, because if you knew the population standard deviation, you'd also know the population mean. So really there'd be no point in taking a sample to estimate something about the mean, because you already know something about it. But we're going to just learn kind of the theory behind this and look at an example, and then just keep in mind that the examples we do where the population standard deviation is not known is more realistic. So a quick introduction. We're using sample means. If you remember back from a long time ago, we can use one variable stats in the calculator or in Excel to calculate a sample mean if you're given a list of values. In some problems you'll have the sample mean already calculated for you. In some you'll get data, and you'll need to use that data to calculate your sample mean. Okay. When you see the term point estimate, remember we're talking about the sample mean. Okay. Just like when we had the point estimate in proportions problems, the point estimate was the sample proportion. It's unbiased, which again just means that the sample mean will represent the population mean. It can be used to calculate a confidence interval, which is what we're doing in this example, and the sample size is important. We'll see later on what the sample size really should be in order to do problems like this. So the equations for a confidence interval, you need the margin of error, so we need a critical value of z, which is z alpha over 2. We need the population standard deviation, the sigma, and the sample size. And then remember the format will be the sample mean plus or minus e, which gives you the small number, which would be the sample mean minus e, and the big number, which would be sample mean plus e. So let's take a look at an example. So if we just go through the problem, we have a random sample of 42 mid-sized cars, so n will be 42. I'll just write that down here. Gas mileage sample mean is 23.8, so sample mean is x bar. And it says we have a population standard deviation of 6.54. We're looking for a 95% confidence interval. Remember, alpha and the confidence level add up to 1, so this is similar to a problem where alpha would be 0.05. And we want to estimate the population mean using a confidence interval. So that's all the numbers we need for E, except we need to figure out the critical value for Z. And we have a table that we can look that up on, so I'm just going to write the value here. It'll be 1.96 for a 95% confidence interval. So the equation for E is the critical value of Z times the standard error, which is the population standard deviation divided by the square root of n. So 1.96 for Z, we have 6.54 for the standard deviation, and our sample size is 42. And again, kind of do these in parts and then write down each part and until you get to your final answer. So this margin of error is 1.978. So to construct a confidence interval, The sample mean is 23.8, and we're going to add and subtract the margin of error. So we subtract first. 23.8 minus 1.978 will give you 21.822 for the small number. And then 23.8 plus 1.978 gives you 25.778 for the higher number of the range. And interpret, we can say we're 95% confident that the mean miles per gallon for mid-size cars is within this range. So that's one way to write an interpretation for a confidence interval. Remember, there's no probability. Remember, the population mean either is in this range or it isn't, so don't say that there's a 95% probability. Just say you're 95% confident. So just like all the other problems, we can use the calculator to do the same thing. So we're going to do a Z-interval. So in your stat menu, under tests, there's Z-test, but if you scroll down a little bit, there's Z-interval. Anytime you have the population standard deviation, you'll use Z. Anytime you have the sample standard deviation only, just S, you'd use T. So we'll get to those in a little bit. But the Z-interval, that's what we're doing right now, gives you two options. There's data and stats. If you had a list of values for X, so all different values of X, and you put that into a list, you could use the data option. Since we already have the sample mean, we're going to go over to stats and use that. Okay, so if you're given values in the problem, just use stats. If you're given a list of values, then you need a mean and standard deviation, then you'd use data. So our population standard deviation is 6.54. Sample mean is 23.8. Sample size 42. The confidence level we're using for a 95% is 0.95, and then we hit calculate. And there you can see the values, 21.822 up to 25.778. That's exactly the same as what we got in doing it by hand. And again, the Z-interval function on your calculator is just a faster way to do it.